So this is for the science project, and today I'm going to be teaching y'all a lesson. This is going to be based on matter. This is going to be based on matter. Solid, liquid, gases, phase changes, different types of energy, and diagrams that relate to those stuff. First of all, we gotta start with the basic thing first. Matter. Matter is anything that takes up space and has mass. So, let's say my water bottle, for instance. Let's say like a water bottle. It takes up mass. The water bottle itself is a solid. I got a liquid in here. It's matter. The air around us is matter as well. Like, so basically everything around us is matter. But there's three types of there's three types of phases: solid, liquid, and gases. Particles in a solid are tightly packed together. So that's what you're seeing right here. The particles, or you can say atoms, are tightly packed, and they don't really move that much. For a liquid, it's not as closely packed together, but it still can't really move freely. Gases, they just move freely. They don't really touch each other like that. They just like, it's kind of like how you're running in the how like you. In fact, let's say you driving like a NASCAR race. You're not really trying to hit a person's car when you're trying to get past them. You're just gonna try to drive past them. That's basically what the particles in the gas are doing. Due to the solids particles, they have a definite shape and a definite volume. Liquid has an indefinite shape but a definite volume, while gases has an indefinite shape and volume. So you gotta keep that in mind. Um, I don't know. Also, let me go back here. There are also different types of energy associated with this, like heat energy, kinetic energy, potential energy, uh, by no, thermal energy, um, light energy, a lot of stuff that can help, that can change a solid to a liquid or a liquid to a gas. So this right here is now a diagram of it. So in this case, I showed a liquid. I showed water in this case. When you're reading a phase diagram, and you see like and you see if it's going from bottom to top, that means it's a heating curve, which means the phases are going up. It's going from solid all the way up to gas. If it's going from top to bottom, it's a cooling curve, so it's going from gas to solids. The first slope that you'll see here would be a solid. The second one that you'll see right here is a liquid. The third one you'll see is a gas. The first straight line would be the melting phase, which is where a solid is where a solid goes into is changed into a liquid. And a boiling phase is when a liquid is changed into a gas. But how do you change the phases? One of the ways you do it is by adding heat. Temperature is like a measure of that heat. We we don't consider it as we don't really use we don't say that stuff gets cold. We don't really use cold in our in terms of science. We just say more like we the form absorbs or the form releases heat. So whenever it's melting, it's absorbing heat. Same as if it's boiling. But if it's going down from a gas to a solid, it releases heat. And basically, heat energy is being used to cause phase changes. Also, in this diagram, it tells you about it basically tells you about the boiling point, the melting point, like into the temperature in Celsius. It also gives you a diagram of how the particles look. And heat energy is basically used to cause phase changes for a lot of them. Potential energy is energy that is stored energy. Potential energy is stored energy. Kinetic energy is energy that's like moving. So if let's say I had a piece of paper, there's potential energy in there because when I use a lighter, I'll light it up, it starts to burn. That's a form of energy. Let's say I have a ball. I'm holding it. There's potential energy. As soon as I drop it, it turns into kinetic energy. So now we're saying that in this case, this is with water again, and we're saying that, and we talking about potential energy and all that stuff. We talk about how the slopes would be the original would be the states, and then the straight lines would be when it's changing phases. When it's on a slope, the potential energy stays the same, but the kinetic energy goes up. Whereas on a straight line, the potential energy goes up, but the kinetic energy stays constant. With this diagram, when it starts to melt when it starts to melt and boil, we consider those to be endothermic phases, which means which means that it absorbs heat. Exothermic releases heat. So, like I said, if you was asked a question in chemistry, like, oh, let's say H2O in gas form goes into H2O solid form. What type of change was it? And it asks you either exothermic or endothermic. It will be exothermic because it went down because it's going down, like it's going from boiling phase to melting phase instead of melting phase to boiling phase. And also it's because it requires less the temperature would go down as opposed to it going up. And I would like to, and just an extra thing when it comes to stuff being like let's say atmospheric pressure would go with this, and this would affect this would affect how much the volume of the gas. But that would be for another day when you understand more about phase changes.